Hi everyone, welcome to another example of trying to find the slope of the line tangent to a polar curve at a specified angle value. Here we are trying to determine the slope of the tangent to the polar curve r equals 2 plus 4 sine theta at the point at which theta is equal to pi. Recall our formula for finding the first derivative of a polar curve as given by dy dx. We are going to apply that to this problem at hand. R is 2 plus 4 sine theta. We need to multiply that by cosine of theta plus, now this is where we need dr d theta, which is simply going to be 4 cosine theta in this case. So we will have that in place of dr d theta in our formula. This is another example of a problem in which, as we simplify, we will have occasion to use some of our double angle identities. As mentioned in the earlier example, this is not required, but it does make your calculations much simpler. Distributing, we have 2 cosine of theta, and then we have 4 sine cosine of theta, but combine that with the 4 sine cosine that's after our plus sign, we have plus 8 sine theta cosine theta. In the denominator, we have both the negative and the sign to distribute, giving us negative 2 sine theta, then minus 4 sine squared theta, and then we have plus 4 cosine squared theta. Where we can use our double angle identities, we're using the double angle identities for sine of 2 theta in the numerator and cosine of 2 theta in the denominator. So we have 2 cosine theta, 8 sine theta cosine theta becomes 4 sine 2 theta as we apply the double angle identity. In the denominator, we have negative 2 sine theta, and we can apply the double angle identity for cosine 2 theta and have 4 cosine 2 theta. We then can go ahead and determine the slope specifically at theta equals pi. So we have 2 times the cosine of pi, which is negative 1, plus 4 times, now we need to multiply pi by 2, so we're doing sine of 2 pi, which is 0. In the denominator, we have negative 2, sine of pi is 0, plus 4 times the cosine of 2 pi is going to be 1. When we simplify that, these, of course, become 0. We have negative 2 over 4, and our derivative is negative 1/2. Let's go ahead and look at our graphing calculator and confirm that this is indeed the case. Under r equals on our graphing calculator, we'll type in the equation we were given, 2 plus 4 sine of theta. Go ahead and graph that. Let's zoom out. We have a lovely Lima sign here. Let's zoom out a little bit so we can get a nicer picture of it. We wanted the slope at theta equals pi, so let's do second trace. Number 2, of course, is dy dx, and we'll type in pi for our angle. And you'll notice it's right down here on the lower left, and the slope is indeed negative 1/2.